Hello guys, today I'm gonna make a guide about the game Virtual Circuit Board, which is a game that I started playing 2 months ago. I don't know when it was released. But today I'm gonna make a guide to introduce it to beginners that have started playing the game and don't know where to start, and people who don't know whether they should buy the game or not, and this should give them a clear representation of what this game is about. So today I'm gonna present the overall UI of the game. I'm also gonna present the inks, which are the components of the game, and at the end of the video we're gonna build our first project, which is gonna be a 7-segment display. So for the first part of this video I'm gonna introduce you to inks, and inks are the components of a circuit board in this game, and inks are just pixels that can be of various colors and represent each component of a circuit board. So you can have, for example, a wire ink, which can be connected to other wires ink and can form the same component. You can have AND inks, you can have XOR inks, etc. For all of the inks that you have below. And each of these ink are part of a ink family. So you have many ink families. You have components, which are just inks used to build logic gates, as you would have in a regular logic gate circuit. There are inks which are considered traces, so you just have the only trace ink is the wire ink, which is used to carry the output to other inks. And you have inks that are called entities. So I have an annotation, the filler, and the non-ink. I'm going to explain each one of them in a second. So ink components are the regular inks that you would use in a logic gate and in a printed circuit. So for example, you have the AND ink, which is going to help you build a AND circuit. So now this AND ink is just useless by itself. And why is that? It's because component inks need to be specified their output and their input. And that's why the write and read are used for. So the read ink is going to specify the input for a component ink. So if I put a read ink there and a read ink there, it's going to specify to the AND gate that it has 2 inputs. And if I put the write ink here or here, whatever, it's just going to specify to the AND gate that it has 1 output. For example, if I take a latch here and here that I set to write here, I'm going to explain what it does later. So this is just a regular AND gate, and for now its inputs are both negative. And yes, now that I've activated its latches, one of its latch, the first input is positive, and if I activate the other latch, its other output is positive as well. And now that both the input of the AND gate are positive, it's just gonna output a positive output, which is just the basic way a AND gate works. What I mean is that if all of its inputs are positive, its output is going to be positive as well. And ink components are various. So you have the buffer gate, which is of this color, and it's just going to let signal through it, but it will have a 1 tick delay. I'm not going to explain what ticks and delay are, but you just want to remember that it lets the output it lets the output be the same as the input. Then you have the OR gate, which is gonna have a positive output if one of its inputs are positive. You have the XOR gate, which is gonna do the same thing, except it won't send a positive output if both of its inputs are positive. So it's just the addition of an AND gate and an OR gate, or something. I don't know. Then there's the NOT gate, which is just gonna invert its input. You have the NAND gate, which is gonna do the same thing as an AND gate and a invert gate, and you have all those gates. You can go into that a bit deeper than I do. Then you have the traces ink, which is just the write ink, as it's called, and the write ink is just gonna let the input flow through it. And compared to the component ink, the write ink doesn't need nor a read for input nor a write for output. So in this example, if it's just going to be a positive output, you can see that the latches outputs a positive output using the write, and the trace, the wire, just doesn't need an input. It doesn't need a read to be positive as well. So it's a very specific component, and it's used a lot. Then you have special components, which in the order are the cross, the latches, which are on or off. Then you have the clock and the LED. So the cross has the ability to help make a different component. So for example, if I put the wire like so, if this wire is positive, this wire is going to be positive because it's the same wire. But if I put a cross there, this wire is going to be positive, but because there's a cross, it just crosses over, and then it's not the same wire as this one. So if this wire is positive, this wire is not going to be positive unless it is specified. But if this wire is positive, this one is not going to be. And it works for every other component. For example, if you put for some reasons you put multiple AND gates, these will be 3 different AND gates instead of being just one same AND gate as it would be in this circuit. So that's the use of crosses. And as specified in the introduction that is there, crosses cannot be adjacent. They cannot touch each other. So if this circuit has 2 crosses in this way that are connected to each other, it won't work. But if it has crosses this way, it will work. So latches are special components that retain information instead of just letting it pass through. Also, latches have the ability to communicate with inputs such as your mouse. So if I go into simulate mode and I click on a latch, it's just gonna become the opposite state of its latch, of its current state. So if the latch is off, clicking on it will set it on, and so on and so forth. And if a latch receives an input, it will also do the same as when interacting with the mouse. It's just gonna become the opposite of its current state. So if I click now, this is gonna set the wire on positive, and this is gonna invert the current output of the current state of this latch. Then you have the clock component, which is just a component that is used to simulate an output every second, every tick. As you can see, every tick it's either on or off. And then you have the LED component, which is just a component that is gonna light up or not depending of its input. So if it receives a positive input, it's gonna light up. If it doesn't, it's just gonna be off. And the LEDs have the particular ability to change color when they receive multiple inputs. So for example, it only has one input, and if it has now multiple inputs, such as there, the LED ink is gonna have a different color. So now it is green instead of being white. And the final family of ink are entities. And entities are just inks that are interpreted as commands, as they do not alter the way the overall circuit works. So for example, if you put a annotation ink there, it will not affect how the circuit works. It will not interfere. Well, it's kind of the same color as the read, so I guess you should be careful with that. But you see, it just works the same. And annotations are used to, just write stuff when you want to specify stuff on a circuit. And then you have a filler, which is just gonna fill and will not alter the way the circuit works either way. It's just gonna fill, and I'm gonna explain what it means later. And then you have the non-ink, which is gonna remove the ink. The UI of this game is pretty straightforward. I'm gonna explain each one of them, starting from left to right and from bottom to top. And first you have the new create project, which is just gonna create a new circuit for you to work on. Then you have the open project, which is gonna propose you to open another project that has been created before. I'm not gonna do that. You have a save project as, if you haven't saved this project yet, and you have the open recently edited project, which is just gonna display the previous saves. Then you have the so you can see them right, but if I make a change, for example, I add a ink there and I do something. No, it's not gonna do that. If I open one of my projects and then I modify something, for example, I make a big trace, it's gonna ask me if I want to undo last action. It can be shortcut to Control Z, but it's just gonna go back. Then you have the redo action, which is as explicit. You have the current project you're working on, and the asterisk means that it has been modified since the last save. Then you have the simulate mode, which is just gonna enable you to launch the circuit. So I'm gonna do that. Now it asks me if I want to go back to the edit mode, which is when I'm going to build my own circuit. But for now I'm in simulate mode, which means that I can interact with my inks and they can do things by themselves. You have the pause simulation, which is very useful when you want to debug things. For example, you see something that isn't working right, and if you launch, for example, I clicked on this LED, on this latch, and if you click on this, it will just go to every tick when you ask it to. It's very useful for debugging. I'm not explaining right. This thing is just gonna specify how many ticks you have per second, how many actions your circuit is gonna do per second. So if I go back to 1, it's just gonna do 1 action per second, as you can see. And if I set it to 300, it's gonna be very efficient. It's gonna be a very efficient circuit. And these actions can go as high up to 1.5 million actions per second, and this is really impressive. This is a lot. Then you have this render with decoration layers, which is just gonna remove the decoration layers that I'm gonna try to explain later. And this is also very useful if you want to debug things while having decoration layers. Then you have the display the inks symbol bin, which is kind of explicit, but it displays the symbols of the ink as specified right there when zooming, and it helps you get a clear appearance of what's going on if there are multiple inks which are kind of the same color. Now, like if you put an annotation right next to a red ink, it can be quite confusing, and well, it doesn't right there, but if it's specified which ink is which, it's very useful. For example, I know that this is a red ink because it has VR, and I know that this is not a red ink, although this has the same color. So this is kind of useful, although I don't use it a lot. Then you have the assembly editor toggle. I do not use it because I do not know how to code in an assembly, and this is not something I'm gonna do in this video, of course. Then you have the introduction guide for beginners, that is there, and kind of sums up this whole video, but if you haven't bought this game, you do not have it yet. Then you have the simple projects. First of all, the introduction project, which is a little bit too complicated for an introduction, but in my opinion. So I would not recommend any beginner to start off with this introduction because it's a little bit confusing, and if you want an even bigger of a confusing introduction, you have a 32-bit computer, which is a computer in 32 bits that uses the assembly editor that was made by the developer of the game, and it helps you represent what this game can do, and it's actually incredibly impressive. Then if we go to the bottom, you have the layer logic, the layers. So you have a logic layer, which just helps you place the inks, so it helps you build your circuit. Then you have the layer decoration, which helps you paint over your circuit, and the layer decoration off, which helps you paint over your circuit. And the difference between these two is that when a component is on, this is when the layer decoration on is going to intervene. So if my AND gate is on, then it's going to be red, and if my AND gate is off, then it's going to be white. So that's the difference between these two, and that's the use of the fillers. So for example, if I have a circuit and I want to make it like a square, I'm just going to put a filler. It's not going to alter the way the circuit works, but then I can paint over it with the layer decoration, although I cannot paint over empty inks, and then it's gonna be something much more presentable, like a square. Well, in this case it's pretty useless, but if you want to make beautiful circuits and on execution do something that looks kind of nice, fillers are your choice of use. Then you have the inks that I presented you earlier in this video. Then you have the none, which is the current ink that is below my cursor. So if I go there, it's going to tell me that it's a filler, and then it's going to tell me that it's an end ink. Then you have the tools. So the most commonly used is the array tool, which is just gonna help you paint stuff, and the array tool is pretty well made. So it has the ability to repeat the number of times you want to paint something. In this case it's 11. The number of spaces between the inks you're gonna paint, so in this case it's 3. The angle, so for example it looks like this. And something very useful, which is the autocross feature. So if I go back in normal mode, for example I made a straight line, the autocross is just gonna do the cross for me instead of having to put the crossing manually. And if you build circuits with lots of wires, this is gonna be very interesting. Then you have the filter, which is just I'm not familiar with it, but if I remember correctly, it's just gonna paint over specific things or something like that. I don't know. And also a very good tip to remember is that if you want to build a straight line, you just have to hold shift, then drag the cursor wherever you want, and it's gonna build a line in the direction that you're taking, regardless of the ink you're on. It's a very, very powerful feature. Then you have the pencil tool, which is just gonna well, you know, help you build very wide stuff. I don't use it a lot, but it can be used, of course. You have the erase tool, which is just gonna have the same function of the pencil tool and will help you erase things effectively. But you don't have to use the erase tool, you just have to use the right click. So you use left click to place an ink and use the right click to remove it. Up. Then you have the color picker, which is just gonna I guess select the current ink you want to work with. So right now I'm in cross, and if I click on the right, it's just gonna give me a right, but it's I don't use it at all. Then you have the selection tool, which is also very useful, and the selection tool has the property to select stuff, and you will be able, for example, if I select this and I do Control C, Control V, it's just gonna copy paste the thing I selected, and it's very useful when you want to write circuits which have lots of components that repeat themselves. So you don't need to use these buttons, just use these shortcuts, and it's very useful. Then you have the duplicate, rotate, which is also very useful, mirror, which is also very useful, and as you can see that there, the copy paste is widely used because these are the same components repeating a lot. And a very useful thing, I'm not going to say that anymore, is the blueprint tool. So for example, if I select this and I click on copy selection, it's just gonna translate the things I selected into a text, and this text can be copy pasted anywhere. And if you copy this text into your clipboard, into your current clipboard, you can just paste selection from clipboard text, and it's just gonna paste what you selected earlier. So the blueprint is very useful when you want to share projects among people. For example, you select what you want to share, you make copy, then you have the text, you put somewhere like in a Discord server, and people can just copy the text in their clipboard and retrieve what you built from this text. So it's a very useful feature. And then you have the bucket tool, which is I'd say kind of obvious, but it just fills with the bucket. Yeah, I think I crashed the project. But it's a useful tool if you're working with lots of wires and you want to change the colors of the wires or some things like that. Alright, so for our first project, I've decided to build a 7-segment display, and these are 7 segments, and we're gonna display numbers ranging from 0 to 7, so 8 numbers, using this display. So let's start with that. I've already created the wires because this is such a pain in the ass to do. I'm gonna use the space tool, which I said is very useful, and I still think it is. Yeah, because I can just drag this way. Very useful. No worries. Alright, so now we're gonna put crosses there for some reasons. I'm gonna explain you later why. And then a latch here with a write, so the output of the latch can be passed down through the wire. And why we want to use the crosses is that because this if we want to use it for multiple numbers, this wire is gonna pass down through here, and we don't want that wire to be part of that wire, because for the simple reason that if this wire is let's say lighten up, we do not necessarily want to have all of these wires lighten up. For example, since each of these wires represents a segment, if we want to display the number 0, we do not want to have this segment lighten up. And if we use crosses, we are gonna have to specify which of these segments we're gonna lighten up. And if we do not use crosses, each of these would lighten up, and that's not what we want. So instead, we have to specify which one of these we want to light up. And we're gonna do that through using a buffer gate. And how does it work is that, well, to put it simply, if so we're gonna enable this latch, so this wire is gonna be on, and since this wire is gonna be on, this latch is gonna receive a positive input, and since it's gonna receive a positive input, it's gonna output a positive input. So it's gonna output something positive here, and we're gonna do that to every segment we want to light up. So we're gonna do that here because we want to light that up, since it's gonna be this number 0. We want to do that here since we want to light up this segment as well. Same thing, we do not want to have this segment light up, so we're not gonna put a buffer gate over there, but we're gonna do that here and here and finally here. So now if we simulate, we're gonna observe that only the segments we selected with a buffer gate are gonna lighten up. Yep, that's exactly what it does. And the advantage of doing that is that when we're gonna use the selection tool to make other numbers, as I'm gonna show you. Now this number was 0, so this number is gonna be 0 plus 1, which is gonna be 1. And if we want to display 1, we also do not want to we do not want to display this segment, nor this segment, nor this segment, nor this segment, nor this segment. We only want to display both of these segments. So we're gonna erase the buffer gates there, and now only the buffer gates here, which is gonna represent this segment, and here, which is gonna represent this segment as well, are gonna work. So now we're gonna try again with 0. Yep, so it works. And we're gonna try again with 1. and it works as well. So it lightens up only the segments we want to lighten up. And I'm gonna do this with every number. So the thing is just to remember that you place the buffer gates which are gonna transfer the signal from this wire onto the wires that you want to lighten up, which will cause the LED to lighten up. Okay, so it seems we've managed to display the 80 numbers we wanted from 7 to 0. And that is already a pretty good thing, because you're gonna want to use the 7 segment displays a lot in your projects, and from what I've seen, it seems to be a beginner specific project, and I'd say that every beginner has gone through this project. So if you manage to do this and understand what you're doing, this is already off to a pretty good start, I guess. So I guess this concludes this introductory guide for beginners to virtual circuit board. I hope you learned some things. I hope it gave you a clear idea of what the game is about, and that you've enjoyed this video. Bye.